Hi there, Ryan from the Headwaters Science Center. And it is pretty close to 3:30. We're running a little late today. But of course, that means it is time for one of our afternoon STEM shows here at HSC. And as I often do on my Friday shows, I'm doing a follow-up kind of program here associated with the book, or in this case, books, that Lee, our executive director, read on Wednesday. So if you want to see Lee read through these 3 books, go back and check out the Wednesday show. It's called Rabbit Reading Numbers, and it'll be on our YouTube channel. So if you want to go back and watch those, you can. But we're going to talk a little bit about some of the ideas from these books, and we're going to do some illustrations here that are kind of having to do with these sorts of ideas that are in this book. And so the first one that I want to talk about is this book that he read called 2 for Me, 1 for You. And in this story, it's about a weasel and a bear who are sitting down to enjoy a nice dinner together, and what they find is that they have 3 mushrooms to share between 2 people. And they find that they have a very difficult time dividing those 3 mushrooms between the 2 of them. They go into all sorts of arguments before it eventually gets resolved by somebody else coming and stealing one of the mushrooms. Spoiler alert, I guess. But I want to talk a little bit about that idea of why that was such a challenge for the bear and the weasel to divide those 3 mushrooms up between the 2 of them. And so I think the first concept we want to talk about is the idea of odd numbers and even numbers. And so this is something you've probably all encountered in your life at some point. You know, a similar issue to what the bear and the weasel were having, where you have a bunch of a thing and you find that you want to divvy them up between a couple people, and you find that it's a challenge to do so because you can't quite get it exactly right. And so I have with me here is a bunch of markers, all varying shades of blue. And if I was, say, hosting a birthday party, as I often do, I like to try and divide up the different colors of markers evenly between all the trays when I'm setting them out, so that one tray doesn't have way more of one color of marker than the others do. Because that's a thing I do almost every week whenever I'm doing an animal theme party. And so what I do when I'm doing that is we'll have 2 trays set out, and I'll grab 2 markers and I'll throw 1 in one tray, 1 in the other, 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 1 in one tray, 1 in the other. And that worked out great. Both of my trays have 5 blue markers, and the blues are a little different here and there, but they both ended up with 5 blue markers. I would be pretty confident saying that my kids that are going to be doing their coloring are going to be happy with the amount of blue that they have and their access to blue. But what happens in that situation if, say, I was to be adding another blue marker into it? And so if I wanted to have 2 evenly batched groups of blue markers, I now have 1 extra one. And so this is the same problem that bear and weasel were having, except instead of mushrooms, it's markers, and instead of having 3 of them, I now have, what would that be, 11 of them to divvy up between 2. And so anytime you're having that problem, where if you're trying to divide a thing into 2 equal parts and you're not able to do it, that tells you that the number that you have is odd. So odd numbers are numbers that can't be divided, whole numbers, that can't be divided evenly between 2. I guess it's true for not even just whole numbers. Whereas even numbers are ones that can. So in this situation, the combined number 10 would be an even number, and 11 would be an odd number. So we can go back and we'll get rid of that one that I added into the pile. And instead this time, let's take one away. Let's say I only had this many. And if I wanted to divide those evenly again, so now I have 9 in my pile, you'll find again I can have 2 groups of 4, and then I've still got 1 left over. So 9 would be an odd number. That's kind of how it works, is you have 1 odd number, and then you have 1 even number. Then you have 1 odd number, and then you have 1 even number when you're counting. So 1 is odd, 2 is even, 3 is odd, 4 is even, etc., etc., etc. But there are ways that you can take an odd number, like 9, and divide it up evenly. So this was something that we were talking about a little bit after we finished recording on Wednesday, is what are some ways that they could have potentially resolved this. So what I'll do here is say I have 3 pieces of newspaper here, 3 ad things from a newspaper, and I have 3 of them here. If I wanted to divide this into 2 groups, I could give 1 to this group over here, I could give 1 to this group over here, and I have this extra one. And so like they encountered in there. 3 is in fact an odd number. And so this one is presenting a problem. And again, we are in the 2 for you, 1 for me problem of we have 3 that we're trying to divide 2 ways. But, as I said, odd numbers are only really a problem if you're only dealing with what we call whole numbers. And there are some numbers that are different than whole numbers. And so what I could do here is I could say, yes, we have 1 paper here, 1 paper here. But you know what I can also really easily do with newspaper? Rip it in half. And so now this group gets 1.5 pieces, and this group gets 1.5 pieces. And similarly, if they wanted to resolve that problem, they could have just cut that mushroom in half. In fact, there's a knife sitting on that cutting board right there that they were using for chopping their spices, whatever they were. They could have taken that and used that to cut their mushroom. Their parsley is what they were cutting with it. And that would have solved the problem right there, where they could have both had 1.5 mushrooms. And I think that's kind of an interesting thing to think about, is the idea of a half, too, because halves are sort of a concept that you'll probably encounter in your school relatively early on, the idea of halves. It's also something that I'm sure you are familiar with just in your everyday life. So what's cool about halves, though, is that we can write them in a lot of different ways. So if I wanted to write how many newspapers I gave to either group there, I could say that I gave each group, I'm going to use a fatter marker for visibility's sake, there's a big pink one here. I could say I gave each group 1.5 pieces of newspaper. I could say that every group has, if I wanted to be real obtuse about it, I could say they both have 150% of a newspaper. I could say that they have what would it be? 3 seconds of a newspaper. And those all mean the same thing. I'm writing them in different ways, but they all mean the exact same thing. They all mean they have 1.5 pieces of a newspaper.
And do you want to show 3 halves with those papers on the screen real quick?
Yeah, so, yeah, we could do that. So this would be 1/2, and then you can see we have 2 pieces here, so each of these pieces would also be a half. So I could, if I was better at ripping, rip them up, and so we have 1/2, 2/2, 3 halves. So 3 halves, so the 2 indicates a half. And so, like I said, this one has the same thing over here. So you could write that one as 3 halves, and you could write this one as 1.5. Ooh, that's another way you could do it. You could do some mixed, could write it like that, 1.5. Again, all meaning the same thing. And so, a really interesting thing that's kind of true too with even and odd numbers that is kind of fun is when you try and mix them together. So, what I have here, I have 3 and I have, let's do 3 and 1. So I have 3 halves, I have 1/2. And if I wanted to add 3 halves together, let's get rid of the halves part. Let's say I have 3 pieces and I have 1 piece here. And if I wanted to add my 3 pieces to my 1 piece, how many pieces do I have? 4, Ryan. Wow, yeah, 4. And so 3, as we've established, is an odd number. 1 would also be an odd number, because I can't really easily break 1 into, divide 1 without ripping it in half again. So 1 would be odd, 3 would be odd, but when I put them together, we get 4, which now is even. And that's always true if you're adding 2 odd numbers together. 2 odd numbers always makes an even number. Similarly, if I were to have 2 and 2 that I was adding together, I still get 4, so 2 even numbers when you add them together always make an odd number as well. But wait, what happens when I have 2 pieces and 1 piece, and I try and add them together? Now we have 3 pieces, and we have an odd. So 2 evens make an even, 2 odds make an odd, 1 odd and 1 even make an odd. Weird little phenomenon there. That's always true, true across the board. But I want to move on to our next book here. It is called Bean 13. And 13 is kind of a cool number, because 13 is another number that is odd. I'm going to gather up all my markers here again. I put them all back like a fool. Now I got to collect them all again. And why don't we, let's try and find 13 of them. Let's see if we can find 13 blue markers. See if we can recreate our problem. They have beans, I got markers, kind of just the way she goes. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wow, exactly right. I didn't even count those. Do I have an eye for 13 or what? And so what happens in bean 13 is that these two, I think they're grasshoppers or something, are out harvesting beans for dinner, and they collect 12 of them, and one of them is like, yeah, there's one more right here, I'll snag it. And they spend the whole rest of the evening trying to figure out how to divide those 13 beans up evenly. And so it starts out, they just have the two of them, and they're like, okay, 6 for you, 6 for me, 1, 2, 3, 4, 5, 6. And you can see we're running into that same problem that we did again, that Bear and Weasel were running into, where they tried to divide it evenly, and lo and behold, we have one extra. We have marker 13 here. And they come up with some different ways to try and resolve it, because they've got a little bit bigger number. The first thing they say is, hey, why don't we call an extra friend over, and we can try and divide it then. They say, who's the friend's name? They say, yeah, we're going to invite April over. And then all of a sudden they're like, okay, now we have a different number of people that we're dividing it between. Maybe we can try it that way. So then they go, okay, now we're doing 3 groups. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So now we have 3 groups of 4, but that gosh darn marker 13 is still there, still presenting a problem. So I say, okay, we'll add one more person to the mix. So they continue, they say, hey, we're going to divide this up 4 ways now. And now everyone gets 3, except there's still one more left. And so they go on and on and on and on, and they try and find a way that they can divide up these 13 beans evenly. And of course, they don't find a way to do it, really. It ends up resolving itself in the end, because they find that all of their friends don't necessarily want the same exact number of beans. But, like I said, there is a solution to this. There is a number of friends that they could have called to have an even distribution between all of them. If they had called 11 friends, so had 13 of them total at the lunch, or dinner, I guess they were eating, you could say this person gets 1, 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 etc., 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 for 13 of them. And so it's unique in that, relative to some other odd numbers, in that there really is only one way to do it. And that is because 13 is what we would call a prime number. And prime numbers are unique in that they are only dividable evenly between either 1, so you could have one group of 13 and that's an even distribution. One person gets all of it, or you could have 13 and everybody gets 1, and those are the only 2 ways you can divide it.
1 for 1 or 1 for all.
Yep. And so 3 is another example of a prime number. There was really no way to do that with other than splitting the mushroom up. Or having 3 people involved, which is how they resolved it as well. But, like I said, it's kind of a unique thing where prime numbers are pretty much always odd. There is one prime number that is not odd, and that is 2. But other than 2, every prime number is odd. So they're kind of special prime numbers, though, because not every odd number is prime. Let's give another example here. I'm sure I've got more blue. Oh, no. There we go. There's one. So what if we were to have, instead of 13 beans, what if we had 15 beans? We're going to add 2 more in there. And I'm sure there's a couple ways we could divide this up, but let's do a quick, easy one here. Let's say they only needed to, well, let's try it with just the 2 of them. Let's say there's only 2 of them here. Establish that we are, in fact, dealing with an odd number, because we know that any odd number is not divisible by 2. So they both got their 7. And we're left with 1 left over. But when they ran into this problem, they said, hey, let's invite 1 friend over, and let's divide it 3 ways. And so, we can try that now. We'll go like that. And now we have 3, and all of them have 5. So 15 is an example of an odd number that is not prime. In fact, is 15 the lowest non-prime odd number?
What about 9?
Yeah, you're right. 9 is also not prime. That's why I need someone behind the camera for me. Yeah, otherwise, it's 1 is, 3 is, 5 is, 7 is, 11 is, 13 is, so yeah, 9 and then 15, yeah. And then as you get bigger, prime numbers get less and less common. They're really common with little numbers because there's only so many ways you can divide up fewer things, but as you get bigger, it gets easier. And so, like I said, 15 is a great example of a number that is odd, but also not prime, because you could do 5 groups of 3, you could also do, or 3 groups of 5, but you could also do 5 groups of 3. So we could go like that. That's another even distribution, so if they wanted to invite 3 friends over, and have the 2 of them plus their 3 friends, they could have divided that evenly too. So that's an example of an odd number that is not prime. Or, of course, like we talked about with the prior book there with their mushroom, these guys seem to have some access to some level of like cooking ware in there. Maybe there was a knife in there and they could have cut that bean into a couple different pieces too. So they could have each had 6.5 beans, like we did with ripping our newspaper there. Or they probably could have even divided up into smaller pieces. I mean, if I had a piece of food that was, half as big as my head, I'd probably want to cut it up into a few pieces anyway, right? Wouldn't want to just eat that all at once. But I think that'll mostly do it for Bean 13. And finally, a book that, honestly, when I looked at the front of it, I thought was going to be a really simple, really basic book that I wasn't going to have a whole lot to talk about. But boy, howdy, is there a lot of fun in this book that we can take a look at. And so, we've had this beaker and this flask sitting in front of me this whole time. And what I want to talk about with those is using numbers kind of as a way of measuring, a way beyond just counting. And so numbers can be indicative of a lot of things. That's kind of what this is about, is how numbers can be used to display information beyond just like an ordered list, beyond just counting. Boy, where is it? And so an example that it gives, here we go, is it shows these milk cartons here and talks about numbers as being a way that this company is showing how much milk is in their cartons. So you have this one here that it's a half gallon, you have this one that is a pint, and you have this one that is a quart. And so in this situation, a pint, there'd be 2 pints in a quart, and there's 2 quarts in a half gallon. So this one is twice as big as this one is twice as big as this one. And this is using what we'd call the Imperial measuring system. So this is the system we usually use in the United States, is the Imperial measuring system. And then you could double this again, and then you would have a gallon. Or if you took your pint and you cut it in half, you would then have a cup, which is a measurement a lot of you are probably familiar with. When we're working in science, a lot of times we don't use those types of measurements. We tend to use what's called the metric system. And so what I have here is roughly 500 milliliters of water. And you can see I have a line right there. It says 500 milliliters right there that I have in my beaker here. And what's kind of interesting is that this is a measure of volume. This is telling me how much water is in here. And what's kind of cool about that is it doesn't really matter what shape it's in. So this flask next to it also has a line on it that says 500 milliliters on it. And I bet if I pour all the water from this beaker into this flask, it's going to go pretty much right up to that 500 milliliter line again. There you go. And so we saw we have a measure of volume there. So volume is how much space is like inside of a thing, basically. Like I said, it doesn't matter what shape it is. The volume can be the same regardless of the shape. The other thing that's kind of interesting with this is the fact that there are lots of different systems for measuring something like volume means that something can kind of have almost like 2 different volumes. So I could say that this is 500 milliliters. I could also say that this is like a little bit more than a pint. A pint is like 480 some milliliters, I think. And so you could, almost as easily say, yeah, this is 500 milliliters, but yeah, this is also a pint. Similarly, if I were to, pour half of this out, I could now say I have about 250 milliliters and about 250 milliliters. I could say I have a cup and a cup. I could say I have 2 half pints. I could say I have 2 quarters of a quart. And you can get your fractions mixed up in there too. Or, I could say I have half of a liter. Lots of different ways to, again, all say the same thing, kind of like we were talking about with our fractions there. And this is true for a lot of different things. So you might have noticed, you know, if you are using a ruler at school, you might have noticed that kind of there's two sides on a lot of rulers. And so there's one side that, like I said, we tend to use in the United States that goes from, you know, 0 over here all the way to 12 on the other side. And that's measuring in inches. And so we have inches, and then there's these kind of little bit shorter lines that are half inches, and then quarter inches, and eighths of inches, and sixteenths of inches. It tends to work by kind of cutting it in half. But then on the other side, you might have noticed it goes 0 to 30. And so that 30 is measuring in what we would call centimeters. So that's kind of, again, the metric version. The version that they use in a lot of other countries is what we call metric. And so 12 inches and 30 centimeters are almost the same. They're not quite the same. But you could, again, say this is, you know, a 12-inch piece of plastic. You could say it's a 30-centimeter piece of plastic. You could say this is 1 foot of plastic. You could say this is 3 decameters or decimeters of plastic, right? It's the 10 centimeters is a decimeter. Yeah. Could say this is a third of a yard. You could say this is 30% of a meter. Again, all ways to say the same thing. The other thing that I thought was kind of neat that this thing has in it is talking about numbers sort of as like labels. And this is something that I do all the time when I'm like running experiments, where rather than like giving a specific name to a thing, I'll just assign it a number. And so it talks about like using sports where like in basketball, rather than, you know, necessarily knowing every single player's name out there, you can say, okay, this guy's number 22. This guy's also number 22. This guy's 13. But they're on different teams. You know, you could say this guy's number 22 for Electra, and this guy is number 22 for, it's like Barcelona probably. And so you can use them as labels too. And like I said, I use that all the time when I'm running my own little personal experiments, is I'll just assign them, you know, one through whatever, and those will be the numbers, and that's, you know, specimen 1, specimen 2, specimen 3. Use them as labels, and so they're not really like counting. We're not using them in that way, and they're not really assigned to like a value, like, you know, a specific volume or anything like that. But they are useful as far as, like I said, telling things apart, or, you know, grading things like this. So you have like our race where they're placed 1 through 3 on there. But there's numbers all over the place, all around us. We use them for all sorts of different things. Money is a great place for doing numbers. So we talked a little bit when we were prepping for this demo about trying to wrangle Peggy into breaking some change for us at the front desk, but she wanted no part of it. She doesn't like being on camera. And so money is a great way to do it. And we were actually, was it you I was talking about this like last week, where I was talking about how when I was a kid I liked to give a bigger bill to the person at the register because I would get more pieces of paper back, and I felt like I was getting more money back as a thing when I was a kid. And so I would give like a $20 bill to buy something that costs $1, and then when I get, you know, a 10, a 5, and 4 ones back, you know, all of a sudden I went from having 1 piece of paper to having 6 pieces of paper, and it feels like I'm winning. So yeah, those pieces of paper like are made of the same stuff. They're made of pretty much the same amounts of stuff. There's not really any difference between them, but we assign different values to them. And so you know, have this number that's just printed on it, and that's, you know, using numbers less as like, I guess, a value thing per se than it is like, you know, kind of a labeling thing almost. It's kind of a mix of both, where in that case the label that's on it is also the value of it, I suppose.
It's like the idea is that just because there's more material doesn't necessarily mean that there's a higher value. That like
I did you could say that I did have more money after that, because like I said, I had 6 pieces of paper instead of 1. I had more pieces of money, but the assigned value of that money overall was less. It was only $19 rather than $20. So, like I said, numbers can mean different things even within kind of the same context. Kind of an interesting thing.
Little exercise in abstraction.
But anyway, that was most of what I had for you. Talked a little bit about even and odd numbers. We talked a little bit about prime numbers. We talked a little bit about fractions. We talked a little bit about different types of notation with numbers. We talked a little bit as numbers as kind of being assigned to a specific value. We talked about numbers kind of in an abstract sense as kind of a labeling type of thing. And like I said, there's numbers all over the place, all around you, all the time, being used in all sorts of contexts. I'm sure you, just off the top of your head, can probably think of a bunch of different ways that you use numbers that I didn't really talk about. But anyway, thank you for watching. The Headwaters Science Center is open 7 days a week, so if you come by on Monday through Saturday, you can come in anytime between 9:30 and 5, and we'll be open. Or if you swing by on Sunday, it's going to be 1 to 5. If you happen to come by at about 3:30-ish, a lot of days we'll be doing shows like this, so if you want to come up and watch live and in person as we're recording these, you're more than welcome to. Sometimes I even will bring volunteers in and have them help me out with some stuff. But otherwise, like I said, thank you for watching, and it'll probably be Carl doing the next show. He usually talks about some sort of prehistoric animal, so if that sounds interesting to you,